Welcome to our first webinar from Maruka, and this one will be about the Toyo Series 6 controller screens. My name is Brad Faulkner. I'm technical support for all of your molding processing needs. Think of me as your built-in consultant. And I wanted to present myself to you on this page since we're going through a presentation so you can see me and learn a little bit about myself. Also an important factor to those questions while we're in this webinar. Everyone's on mute so there's not chaos, and you still have the ability to ask questions. You may either see a chat button or a Q&A. Either one you may see would work. So I want you to feel free to ask any questions. What I will do going through is, as I finish a page, I will look to see if there are any questions and then go forward. But once again, thanks for attending. And, you know, a lot of times when you're in a presentation or a classroom setting, sometimes you think of questions to ask after it's over. So also wanted to show you this so you can maybe jot this down. My cell phone number, so you could text me anything at any time. And also my email address. If you write this down and you think of something later or something totally unrelated comes up you'd like some advice on, please feel free. I'm here for you at all times. All right, so let's get started. We're going to start with the main menu. I really like the main menu on the Toyo. It is similar to some other machines that I've ran in the past. I like having a central place to go to so that you don't get lost trying to flip through and go through certain pages. You can just come home, look and see what you're looking for. And another thing to notice is that you can lightly see behind the name of each page a number. So this is if you look at the first one, you see a 10, then to the right, 11, 12, 13. So the valve gate page would be on page 13. 14, 15, a screen selection page. You could go to 15. Going down to the bottom, password, enter your password. That would be on page 100. So you'll see these as you see the number 2 menu up in the upper left-hand corner. And this helps you as well. But along the left-hand side, you still have the quick keys to look at. You see, like everything that says injection plasticizing, you see all the pages to the right. But if you see that same logo across the bottom, that's a quick key where you can just press and go straight to injection plasticizing. So lots of options here besides just looking at which page you want to go to. You also have down, you also have down right above in the lower left-hand corner, you have the back and forward arrows there above where it says off. Back and forward, you can utilize that. And also if you need a calculator, you'll see to the right of that, there's a calculator. So you can go straight to that. But, great page. I never get lost when I can always go back here and just go to main menu and come back to that page. This is a quick look before we go to our first page to look at the operation mode keys. And you'll see there, of course, the primary one's off, reset. If you have an alarm, you press the reset button to silence and clear that alarm. Mold set for slow movement of the clamp and the ejectors. Manual, in manual, you can go at full speed. Always want to be careful with that. When you're not sure, use mold set. Until you are sure, then you can go into manual and go through your movements. And then, of course, when you're ready to start semi-automatic and fully automatic. Now, semi and fully automatic, you'll see below that screen it says to enter semi or fully automatic, the double pressing system is adopted for safety reasons. So you wouldn't want to accidentally hit it and not mean to go into semi-automatic or fully automatic. So to guard against that, it is a double press. But if you forget the double press and you do the single press, you will get a message, as you see below, 18 or 19, press full auto key again, or press semi-auto key again, and you do it, and that's your second one, it takes off. So that works well. Some descriptions to the right of mold set, manual, semi, and fully automatic, pretty standard within molding machines. Also a note at the bottom says when the motor on or off switch is in the off position, the mode keys are invalid. In addition, the following message 15 will be shown, and then show an arrow over there. So just a little overview of that. And you'll see highlighted core in, core out, core 1, core 2, and air 1 and 2. That can look a little different depending on how busy, how many different options you had put on, but you would be able to see that on your particular operation mode key. Okay. Talk about passwords for a moment. This is something that other machine brands, they use the passwords, or maybe sometimes you don't see as many passwords, or it's not really pressed by different companies. We do think it's important to have this password system in place. It's important when you're looking to see what changes have been made over the past shift or days, and to be able to look and see who made those changes in case you need to go back and educate them on something that was done wrong, or anything like that that you need to look at. The setup procedure, you have the default usernames, service manager. For service, password has been assigned at the factory. Toyo's service staff uses this username and password. That's unique. But for the manager, no password's been registered, and the user can register his or her username and password. So when you're doing this, and one thing I like to mention to a question that we had at one point was how many users can be registered, because that manager is going to be the one who puts in who the users are. That's their primary job when it comes to the controller. And it is up to 512 users can be registered, probably more than most folks would ever need, but that is the maximum that is in the system, or can be put into the system, 512 users. You've got operator, and you see this in the lower right hand. You got the operator, you got the processor, there's a simple group, and there's maintenance, and of course, as we spoke about, the manager. And you'll see highlighted to the left, if no operation is performed for a specific period of time, the username should return to the default, and that default is normally the operator. What that does is it keeps just anybody from walking up to the machine and making a change that they're not trained for. So once it's been a certain period of time, and I believe that is adjustable, you can, if you walk up to it, if an operator walks up to it, for example, they can see anything. They can go to the pages, and they may be writing down process information, but they can't make a change. They can't change a process. So if that's the case, though, you walk up and you do need to change something, you just go into your username and you put in your ID, so that it then goes over to maybe a processor or something like that, and then you'll be able to see that now you can make changes. Before we get into the main pages, a quick look at, because we just mentioned this, at menu number 43, the setup record. Setup record, you'll see they're all numerically numbered, and there's the date and the time and the name of what was changed, and what the unit might be, inches per second, pounds pressure, position, anything like that, what the old value was, and now what the new value is, and the username. And then you can see that. And I find that really convenient. I would recommend it to anybody who works the machines. When you start a shift, go to this page as soon as you start up. I can't tell you how many times I came in and I asked, how did the machine run? Oh, it ran great all night. Well, then I go to this page and then saw that over the past 8 hours, there'd been 20 process changes. Well, that tells me it did not run all night. So this is a good check and balances for you to look at. Okay. All right, no questions on that. This is a good page to start with as well. It is a busy page, but it's a great page to have if you're going to be if you've got that one page that you want to print. This would be it. That would give you a good snapshot to the overall process. So busy page, but good information. So let's look at a few items on here just to tell us a little bit about any page you might go to. Number one, any values that are wrote in yellow would indicate that they are actual values. That's the actual position or the actual time or the actual stroke. So anything in yellow is indicating an actual. The green numbers that you would see, they are settings that will be saved to data memory, and those are changeable settings that you can make. Then you've got the blue. You'll notice you'll see some blocks here that are blue. Those are reference values. They are read-only. They cannot be changed. Normally, they refer to another setting that is changeable, and they're not making it changeable in multiple places. You have reference in multiple places, but there's only one place to change it. For example, that mold close that you see in blue there is blue, so it's reference. But if you go over to the left, you'll see in the mold open, there is 9 inches, and it can be changed there. So any change you make there, you'll see in the reference. But those are just for reference, and you cannot make any changes there, which you'll see that as we go through the other pages. But a great overall page to show you most of your process, the key elements of your process. And like I said, a busy page, but a very informative page that would be great to print and put into a mold book to have as a reference. Certainly the heartbeat to a process is your first stage filling, the velocity of pressure transfer going into hold, and I refer to these a lot of times as filling being first stage and packing the part out in the hold phase being second stage, and then along the bottom, the plasticizing. Okay, very important page. you'll see the different profiles that you have the ability to do in the injection phase, up to 7 different profiles. This one right here shows 5. Also, these are screw positions along the top, and you're looking at this from a linear position of the screw from the shot size going filling. And then the second line is each segment's speed in inches per second. And then you have the high pressure limit. That's a limit that should not be reached, but it should not be set so high that it does nothing for you, but allow pressure to go too high and then maybe blow your mold open. But you don't want it so low that you are continually reaching that pressure and hitting your limit. You do not want to be pressure limited, especially you doing it to yourself. That value should be set about 10% higher than what your average maximum pressure is when you're filling. Also, you can segment that high limit pressure if you want to stagger the pressures within the different stages. You can do that. I never do that. I'll usually just pick the one. It would depend on how tight and sensitive your process is. Then we look at, as we leave first stage, we look at how are we going to transfer. In this case, and this is the standard, your VP switchover mode will be stroke, which means you're transferring by screw position. That is the standard, what some people call it D2 process, meaning that you are transferring, by screw position. And then to the right of that, where it says stroke, it shows that VP setting. And that VP setting is the actual screw position in which you're switching from velocity of feel to pressure in hold. So that's the VP setting, is velocity to pressure. Okay, and then we go into hold, and you'll see hold. In this case, you can have multiple settings there also, but you'll see that there are 4 settings, 4 different pressures with 4 different times, or they're all the same time, but 4 set at a half a second, meaning this would be a total of 2 seconds of hold. And you also have the speed of the screw pushing it, in this case 0.39 inches per second. Let's talk about profiles, and because you'll see down the lower left-hand corner, there's profiling being done there with the RPM and the back pressure. So I put a little label there that says profiling with question marks. I think profiling can be troublesome. It can get you tied up in knots and make it difficult for you to make incremental changes to your process without getting yourself sort of painted into a corner. For example, let's look at what was done in the injection profiling. So basically that's saying that from 1.5 inches to 1.4 inches, you're going 0.80 inches per second. Then when you get to 1.4, you speed up to 1.5 inches per second, and you do that until you get to 1.2 inches. At 1.2 inches, you change. Well, no, you don't change. You're staying at 1.5 inches down to 1.0. Then at 1.0, you change to 0.8 inches per second, slowing down until you get to 0.8 inches, and then you slow down to a half an inch per second. But see the confusion there as someone was doing this, they kept the same speed and just wasted a profile and may confuse someone, because you're actually using the same speed from 1.4 down to 1.0. There's no need to overcomplicate it. Also, when you're looking at hold, you see 4 segments there. That's really dictated by your part geometry and what's needed. Most of the time, and I ran some very difficult parts, high tolerances or tight tolerances, and thin walls. And most of the time, I ran one profile of pressure and time. Sometimes I may have found it necessary to run two. In 30 years, I can't really tell you a need to ever run more than two stages of second stage pressure. And so I think profiling can be a little complicated. Looking at your plasticizing, I'll be honest with you, 99% of the time I run one profile of RPM and back pressure. I don't see the need for all this profiling. I think that takes you away from keeping it simple. I'm a big proponent of keeping your process simple, but doing it correctly. You may have times when you need to profile, but I'm going to tell you most of the time you do not. So just to go back and hit some of the areas still on this page, let's look at that fill time limit there at the switchover area. We had it switching over by stroke at 0.2 inches, but there was a timer in the middle that says 10 seconds. Right off the bat, to me, that sounds high. We can't see on this page what the actual fill time was because of the time this snapshot was taken. But normally, just like your pressure should only be set 10% higher than the highest pressure you're seeing, that timer should be set only about 10% higher than your actual fill time. That's there to be a second ability to prevent anything unfortunate from happening. In other words, if you blocked a cavity and you never made it down to 0.20, having that 10 seconds would allow you to be putting full first stage pressure on this shot for up to 10 seconds. And that would probably blow the other cavities that were not blocked and overfill those, and could cause tooling breakage, certainly stuck plastic. But if your normal fill time is only a half second, then you would set this at 0.55, and if that happened, it would barely go over the standard fill, and then it would stop you being in first stage, and you probably wouldn't have anywhere near the damage, or probably have no damage or stuck plastic. So always want to keep that high pressure limit and the fill time limit set about 10% higher than actually what you're going to see. Getting down to the bottom again of the plasticizing, we'll start out over on the left, seeing the plasticizing delay time. That's always a good thing to have in case your geometry of your part allows for a very high cool time, but it's a short stroke, so the screw gets back, really soon. And instead of letting the whole shot sit there and see that heat, you can just put the majority of that time in the plasticizing delay and set it in such a way that by the time the screw gets back, there's only about 1 to 2 seconds before cool time's over, and then the mold opens. So great to utilize plasticizing delay time in those circumstances. There's something a little unique here, and it's unique to my knowledge to Toyo, and that is in the lower middle section, the SRC2. The way you turn this on, there's not an on-off to this. It's turned on by you putting time in the timer section. So in this case, by putting 1 second in there, it turns it on automatically. What I've read about this is that it helps to stabilize the shot compression. So consistency shot to shot is improved if you utilize this. I would like to see a consistent shot to shot even if you don't utilize this. But sometimes things happen beyond your control, and it's good to have something that can help you when you've just done everything else and you're having some consistency problems. What happens here, and I have to admit that I've not used this or really seen many times when there's ever a need for it. I've not seen anybody utilizing it. But when the screw would be turning to build the shot, and it got to your shot size of 1.4 inches there, at 1.4 inches, instead of going ahead and sucking back, it would actually stop at 1.4, and it would pressurize that shot for 1 second at 232 pounds of pressure times 10. So you'd pressurize that shot. So that would make that a tighter, more consistent shot. And then it would suck back, and then you would continue on with the cycle. So there is some benefit that I've read about that can come from this. And I've wondered many times when I've seen a situation when this could be used. See a question that's came up asking if we know of any problems that have been solved with this. I don't. Maybe someone else does. If I hear of it, I will let you know. But I did run across one time. I didn't think about it until after the fact. I went into a customer, and they were having some problems making a very large part, and a large thick wall part with a clear material. And when I went in there, the problem they were having was that they were having some problems getting the screw back without having a torque issue. When I looked, they were running the back pressure far beyond what was recommended for that material. So that was creating a high torque. And I was going in to look at the process. And when I looked at it, I felt like that was the problem, and asked them why they were running that higher. And they said the reason was if they didn't, they would have a lot of voids or air bubbles. So I'm a firm believer in keeping your material settings, within the recommendations set forth by the material suppliers. So I asked them if it was okay if I lower the back pressure down, and I did. And when I did that, I saw all the bubbles come in that they were talking about. Well, then I looked and saw that their heats were on the low side, which would also have caused a torque issue when it was plasticizing. So I asked them if I could bring it up at least to the minimum of what was recommended. And they said, well, you can try, but we've had discoloration when we do that. Sure enough, when I raised the heats up just to the minimum of what was recommended, it started taking a clear part and turning it smoky gray. So they weren't processing this wrong. They were processing based off what the part geometry dictated. So I had to lower the heats back down until the grayness went away. And then the only way to get rid of those voids was to run a higher back pressure. So I understood their dilemma. Later on, when I was many hours down the road, had left that customer, I started wondering about the SRC2. The SRC2 may have been a way to compress that shot, to compress out all those air bubbles without running the back pressure too high. So I thought of that and wondered if that would have helped. Later called the customer and got a voicemail and left that suggestions, and never heard anything back, so we may never know. But that is what SRC2 is about. Then we step over to SRC3. That is a little bit different. As you can see, there is an off and an on, and this is supposed to help with the stabilization and guarantee that you had no leaking of the check valve. To utilize this, it is specified that the only time you turn this on would be if you were using the specified Castle check head tip, and the check ring that goes with that is required, plus a hardened barrel. So that is the recommendation, and that's also something that can be used to keep an even more stable shot-to-shot than even SRC2. So I've not seen a customer using that yet, but I've seen some data that shows parts that are more stable with either one of those. So if you're having problems with standard methods, keep that in mind, and that's something maybe we can work on together. Also, down at the lower right hand, there's a what looks like a multicolored printer with paper going through it. That is your print button, and anytime you're on a page and that's available, if you press that button, it will print the page you're looking at, either to a printer if you have a printer hooked up, but most of the time you don't see many printers anymore. We have a USB port where you can put a flash stick there, and by pressing that, it will dump that screenshot to your stick. Then later on, you can take the stick to your computer and you can bring that up and print it or email it or whatever you'd like to do. Okay. One other thing I'd like to say before leaving this page, one thing I like about the Toyo a lot is if we look at the very top center, you'll notice that not only does it show the page number with the name of that page to the left, but in the center, it's always going to show the model, in this case SI 200-6, the injection unit that is used, in this case H370D, and a 55 millimeter diameter unit. That's so important because a lot of times if I get emails, I see right away what injection size we're dealing with and what machine size we're dealing with, and I just like having that, and that's something so simple that I see a lot of machine manufacturers overlook, having it on every single page like that. Before I move on, we've got a question, and the question was, the plasticizing delay, is that also on a different screen? It would be on the overall screen, and let's see if we go back to the overall screen, and we will see there, yep, plasticizing delay, it is there. And you can see it's not referenced, so it could be changed from that screen as well. So it is on another page, but I think those are the only two places you'll see plasticizing delay. Good question. Thank you. All right, let's move forward. Okay, this is a page, menu page 11, plasticizing sub setup. It's a page that not a lot of processing going on here, but there are a lot of items here that can be cut on or off and utilized for benefit. The thing that I think you'll notice right off the bat is most of these are off. So these are things that are not standard, but there are some possibilities there that you could you could utilize. And the reason why you're seeing 2 pages, this page is so large that there's actually a bar that you can slide up and down, and we're looking here at the top of the page, and down here we're looking at the bottom of the same page. So let's start out with what I have here to the right that shows the speed slope and pressure slope. And in this case, you're seeing that off. And you're also seeing plasticizing control mode, also speed slope and back pressure slope off. These speed and pressure slopes, when you're on an electric machine, when you tell, if you're profiling and you tell it to go from one speed to another, an electric machine is going to try to do exactly what you tell it to do. And that can be a pretty sharp change. And that can cause a machine not to run as smooth because it's a stop-start immediately at 2 different speeds, 2 different pressures. So if you were to see that was making the machine a little jerky, not smooth, you would turn these on, and that would make it do a gradual change from one speed or one pressure to another. So that could be beneficial. And it says, note, the pressure slope function does not work in the filling process unless using multiple steps. Like what I showed you, I normally use one pressure max. And those are just max anyway. You're mainly controlling speed there more than anything else. Also, over to the left, you can do your injection sequencing and do it right there on that page. And that, in this case, plasticizing, then shut off, and then nozzle back if you're running a sprue brake or something like that. On over to the left, we've got one called, that we're pointing out, that says just pack hold pressure. So the just pack hold pressure is off in this case, but it says this is used to stabilize parts using decompression after filling and before packing. So that sounds different than what we're used to. Let's keep that in mind, and we'll look at that in a little bit more detail later. The block to the right of that says ramping up of injection pressure and ramping down of hold pressure. So if you follow that arrow, you're going to see this V mode. And the first one is injection velocity mode. The next one is hold pressure velocity mode. And you'll see both of them set on mode 2. I will tell you that when our guys come in and install your machine and get you all set to go, they do a fantastic job. And they spend a lot of time with you, going over the screens, getting you ready to put a mold in, helping you with the mold being set up. And these are always set as a standard on mode 2, both of these. I've played with these a little bit in the past. One thing I do like about it is Toyo is keeping it simple. You've got mode 1, mode 2, mode 3, mode 1 being the fastest, 2 middle of the road, and 3 the slower, more like an old hydraulic machine. What this is used for is to use your ramping speed. We'll look at injection V mode first. How fast are you getting up to your set speed for injection speed? Middle of the road is safe. I like doing mode 1. I like getting to my set speed as soon as I can, as long as I'm not spiking over my pressures. If I'm spiking over my pressures, then I will settle with mode 2. But then after you filled in first stage, you've got to slow down to transfer into hold. If you transfer into hold too fast, like with mode 1, you'll actually shoot below the pressure you want, and then it'll have to take the time to come back up to your pressure setting. That can actually take longer to stabilize. Mode 2, it works pretty well. What I've seen with mode 2, it will transfer and then come down fairly quickly to your pressure setting and then hold at that pressure setting. If you went to mode 3 for hold pressure, V mode, it would actually take a while for it to bring the pressure down to what you want it to be, and that's giving you excessive pressure and hold that you don't need. So that would be mode 3, which, to be honest with you, I can't think of a reason I would use that. Maybe for a specific material it would work well, or help, maybe like a PVC or something like that. So most of the time the standard is mode 2. There's something below that that says SNF stroke, and shows where you can start this SNF stroke. And that is if you're ever in a situation, maybe it's not due to how you set up the process, but maybe you're using a material that's really hard to flow, like a really hard to flow polycarbonate. And you had no pressure issues with other materials in that machine, but for that machine, you're finding yourself pressure limited. And what this SNF does is it allows for it to run pressure limited, but it smooths it out. I never want you to run pressure limited, but if you have no choice but to run pressure limited, you would want to turn the stroke on so you could keep it running smoothly. One thing I don't like about this is SNF, what it means. What does SNF stand for? It stands for supernatural flow. We're going to have other webinars in the future where we're going to talk about scientific molding and processing. And supernatural flow doesn't sound very scientific, does it? Maybe it's something in the translation. But that's what SNF is. Okay? Back to that Just Pack that we saw. Just Pack is a control. That's where we had said that when you filled it, it would actually do a suck back after fill before you went into hold. And the reason for that is so you don't have an overabundance or an excess of holding pressure. Because the excess of holding pressure in between first and second stage, that can create thickness deviations throughout the part and molded in stress. So if you look to the right at the picture of the standard control, you'll see the discoloration, which indicates stress when you're looking at a part under a polarized lens. And what happens with residual stress is sooner or later it will relieve its stress, and then that will cause a warped part after it's been molded, maybe even in the field. So by using the Just Pack control, you can see the same part underneath the polarized lens, and you see the stress is gone. And when the part was measured, the thickness deviation difference throughout the part was reduced. So a flatter part, I was actually told that part was harder to even pick up off the table. It was so flat. So when you're making a part like that, that's what you want, a flat part with no stress. So this is a tool that Toyo gives that can help you with that. As you can see below, reduce stress on the part by eliminating excessive hold pressure, reduces thickness deviation by 50%, and create some more consistent and reliable process control. So something new there you may want to play with if you're having any parts that have issues with thickness deviation or with built-in stress. Here we're on page 15. Page 15 is a entry field where you see all of these are on or off. Select on or off and then press the entry key to set it. This is a screen selection where by turning this on or off, you will actually see these parameters turned on other screens. For instance, if you were going to do a auto heat up control, when you went to your heat page, by having this off, that's not on there, but if you turn it on, it would give you that auto heat up control. Graphics subsets would be available if that was turned on, not if it was turned off. We've got a real neat feature that I'll talk a little bit about probably in part 2 or 3. If you'll look here where it says melt-con viscosity measurement, that's turned off. That is an option. And if you bought that option, this is where you would turn it on, and it would be linked to the heat page where we could do some auto controlling of viscosity, which can only be a good thing because we always have to worry about viscosity shifts due to lot changes. So that's what this screen is about. It's all about having, turning some things on and off on different pages. Okay. Well, we had some technical difficulties when we started this webinar today, part 1. And so that took about 15 minutes of our time, and I apologize for that. But this is where we stop for today. Let me check the questions. I've got one question here that says, the problem is when an alarm comes on, several screens show different graphs before seeing the actual alarm on the screen. Is there anything you can do to fix this? That could be if you've got an option turned on to print the alarms to the USB. If that option is used, then you will see these graph screens popping up before you actually see the alarm. So that is a possibility. Okay. Any other questions anybody will have? Hopefully we'll be able to address those as we continue on into part 2, which will be next Wednesday on June the 3rd. And then it will probably take another session, which will be part 3, which will be the following week on Wednesday, June 10th, same time, 2 o'clock Eastern. And we hope that you guys will continue to attend these webinars and that this is beneficial to you. Thank you for letting us come to you in this manner. And I think it's something that can benefit us. It's easy to reach a lot of people, and it incurs less cost for all of us to do it this way. So we're going to continue to look at other ways we can utilize webinars. I'm already thinking about a processing webinar, maybe looking at some case studies and looking at other ways we can utilize the webinar format to everyone's benefit. So thank you for your time today, and I hope that you'll attend the next session of the Toyo controllers when we go through part 2. Thanks again for your time. Bye-bye.